you all ready?
Mm-hmm.
Are you ready? Okay. Yeah, I'm assuming where the camera is, but welcome everybody. It is 9 o'clock, and it is my pleasure to introduce our speaker today, Sarah Knudsen. She'll be defending her master's degree, and this is her master's defense presentation. For those joining you at home, if you have any questions or can't hear us, please in the chat let us know. We will reserve time for questions at the end. But I've seen Sarah's presentation. It's a wonderful presentation. Provides a great overview of her research. It's a very diverse and complex research project, especially for a master's level, all the way from flying in an airplane and counting cormorants to the lab, dissecting those animals and figuring out what they ate and everything in between. So there's a lot to do with this project. It's about a 40-minute or so presentation. I'm not going to get into a long, drawn-out story and tell anecdotal tales about Sarah, other than that she is a wildlife student from our program, graduated here in May of 2023. This project came about that time. We were looking for a student, and it worked out. We got a great student. And so Sarah joined us, I believe, at the end of that summer in your first fall field season. Yep. Hit the ground running and has done an excellent job since that time. So with that, Sarah, I'd like to turn it over to you. And again, we'll go allow her complete time with her presentation. And then at the conclusion of that, we'll have some time for questions. All right. Thank you, Sarah, and the floor is yours.
Sounds good. So I'm gonna jump right into it because I have to present about 3 years of my life and research on double-crested cormorant impacts on catfish aquaculture in the Black Belt of Mississippi and Alabama in about 40 minutes. So throughout this presentation, I'm gonna walk you through the who, why, what, how, and what I call the wow factor of this study, the wow being the results. But first we gotta get through the who. So the primary species of interest in this study is the double-crested cormorant. They're a fairly large gregarious water bird. You'll often see them in groups of 2 to well over 200. And they are also migratory. So between April and October of every year, they will be in their breeding range, highlighted in orange on that map. And then starting around October, much of this population migrates to southern and coastal regions in the United States. And you can really see from this map in the blue that they are really dependent on these coastal regions because they are.
There's a comment by Brian Dora that they cannot see your slides.
It is.
Oh, Wilder can.
Yeah. And I'm not seeing all I'm seeing is the view of the room.
Brian, I hate to say this, but it sounds like a user error.
Okay. Yeah, Hunter can see them.
The second.
Corey can see the slides.
I gotcha. Okay.
Okay.
Yeah.
My apologies for interrupting, but
Yeah.
No, I got you. It's fine.
All right, so you're good. Thank you.
But so they're really dependent on these coastal regions because they are a diving species to catch fish. On the flip side of that, large river systems such as the Mississippi River system allow cormorants to overwinter much further inland. And every cormorant can eat up to a pound of fish per day. And this is where the other who in this project comes in, is the catfish farmers in the Southeast, but specifically in Mississippi and Alabama. Again, they're right on the Mississippi River. And I think you can see where I'm going with this, where thousands of cormorants overwintering on catfish farms does not spell out good news for a catfish farmer. And within Mississippi and Alabama, there's two primary regions of interest: the Mississippi Delta region, which constitutes most of U.S. catfish aquaculture, and the majority of Mississippi aquaculture specifically. And then there's the Black Belt region, which is that crescent spanning between Mississippi and Alabama. And this is the second primary region of production. It constitutes all non-Delta Mississippi aquaculture, as well as all of Alabama's catfish aquaculture. So that is the who in the study. Now we'll be moving into the why. Why are we looking at this? So as things tend to do, it comes down to money. Both catfish aquaculture is incredibly important for national and local economies, especially in the Black Belt region. And a lot of farms right now are struggling just due to high feed prices and competition from imports keeping the return on investment low. So there's a very narrow profit margin that farmers work within, and cormorants can eat into this significantly, both in lost revenue from lost product, but also in increased input costs from hiring on additional manpower to try and scare cormorants, truck maintenance, so that's oil, gas, and tires. You can ask Michelle. I went through about 4 tires in my study because catfish spines can and will pop a tire. So ultimately, a lot of farms are going out of business right now. This is a farm that was not on my study, but it was neighboring to one of the farms in my study. I took this picture from the field. So ideally, we can understand the factors that drive cormorant depredation, better inform policy and management, improve harassment outcomes, and hopefully improve profitability, just making the lives of these farmers easier. And double-crested cormorant depredation has been fairly well studied in the Delta region of Mississippi, but less so in the Black Belt region. Again, the Mississippi Delta it constitutes more of the production, so it was prioritized. So there's regional differences, such as differences in farm and management characteristics. Typically in the Delta region, we're seeing hybrid catfish, which is a cross between a blue catfish and a channel catfish, and channel catfish in single batch production. So they stock a single cohort of fingerlings and grow them to harvest within a pond. But in Alabama, we see mostly channel catfish multi-batch production. So it's channel catfish, which typically grow slower, stocked throughout the year so that there's continuous harvest off of a pond. And there's additional landscape differences between Mississippi and Alabama that can all affect cormorant depredation. So that brings us into what do we know about cormorant depredation? This is going to be mostly from farms in the Delta region. And roost sites are a variable that comes up fairly frequently in this literature, with many studies seeing increased number of cormorants on aquaculture as the number and proximity of roost sites to aquaculture increases. And this is an image that I took from Google Earth, 15 kilometers from the surface. This right here is a wildlife management area. It's a little oxbow. And this kind of exemplifies what a roost site might look like for a cormorant. It's trees overhanging or in water. And this is a catfish farm right here. But often they don't have to be that close for it to matter. In the Delta, we're seeing 15 to 20 kilometers between night roost and daytime foraging locations. And in the Black Belt, it averages about 7 kilometers. So there's also differences in the amount of surrounding aquaculture and aquaculture density for farms in the Black Belt region than the Delta region. And this can affect cormorant depredation. This, on the left here, we have a typical Delta farm. It's a little bit larger, but so is the Black Belt on the right. And the main takeaways from this, I want to point out that the camera is 15 kilometers from the surface, so you can kind of get an idea that Black Belt farms are typically larger on average than Delta farms are. Black Belt farms are additionally more spread out and more irregularly shaped. So they are less easy to manage than in the Delta region. And all of this culminates in differences in management factors between the Delta and the Black Belt region, with studies examining differences in levee ponds and fish density and pond size. And a lot of these factors are what I looked at in my study, which we'll get to in a minute. Additionally, we see differences in seasonal timing throughout the year of cormorant occupancy and abundance on aquaculture, with a small peak occurring in about November and a larger peak between February and the end of March. And this makes sense as you picture cormorants are migrating down from their breeding range through the Mississippi River system, and then they funnel out further into the Gulf. But many do stay on aquaculture, so that's that plateau there. And then as cormorants are migrating back up, potentially more cormorants are going to be stopping over on catfish farms, which constitute a very dense and abundant resource of food, because breeding is a very energetically expensive endeavor. And we see this reflected in the diet of cormorants on catfish aquaculture as well, with the most significant consumption occurring between February and March. But in natural systems, we're typically seeing a very diverse diet of species that are typically schooling mid-water, slower. So catfish are not a typical prey item for cormorants because they're benthic, often under logs. And if you're familiar with noodling, they are not typically on the surface of the water. So our goal was to quantify cormorant abundance, fish consumption, and economic impact on black belt catfish aquaculture, with the economic analysis part being primarily done out of house. My two components were the diet and abundance chapters. So within the diet chapter, we're going to be looking at what are cormorants eating, the species in the diet by percent weight and consumption. What are the patterns of this catfish consumption? Are there seasonal differences in the timing? Are male and female cormorants eating different amounts, different sizes, different species of catfish, as well as differences in catfish species and size? So then for the chapter 2, cormorant abundance, how many cormorants are on black belt region sites? And what are the management and habitat level characteristics that cormorants are looking for when they select a pond for use? So that is the what, and now we move in to the how. Look, we're almost done. So first I had to select my sites. I acquired the recent location data of catfish farms in the black belt region, and I digitized those ponds. And you can kind of see that there's 3 hotspots of catfish aquaculture within this region. So we kind of narrowed our focus to those regions or those zones so that we could maximize the amount of aquaculture that we would be including in the survey. Then I randomly selected 30% of those farms, and I ensured that each selected farm was representative of the overall farm size within each of those zones. After that, I got to do the aerial surveys. So aerial surveys were conducted between October of 2023 and April of 2024, then October of 2024 and April of 2025. So throughout 2 winter seasons, we sampled every other week, ideally. That often didn't happen between those 2 months. And it occurred between an 8-hour window, so 1 hour after sunrise, 1 hour before sunset, to coincide with active foraging hours and FAA regulations. Generally, we flew about 500 feet in altitude, but could drop lower depending on how many sols were below us. And we flew about as slow as we could while staying in the air. So throughout this, I counted the cormorants on ponds for each of these surveys, and I took images on a subset of ponds of various flock sizes so that I could later account for my personal observer bias, which we'll get to do a little fun exercise for later. All right, after that, I conducted farmer surveys. So I went up to the farmer and I asked them what the pond type. So was it a levee pond? Was it a watershed pond? Batching strategy, was the pond multi-batch? Was it a single batch? Oxygen level, head stock per acre of catfish, the size of the fingerlings that they stocked, and the species for each pond for each sample period. And then I spent a very long time in ArcGIS extracting pond sizes and then adding that up to get the farm size. And then these indices, which I'll get to in a second because they need a little more explaining: distance to nearest activity center and distance to roost site. And those were recorded again for each pond for each survey period. So for these indices, they're not true indices. Starting off with pond index, it's just a count of the number of ponds within 35 meters of the focal pond. So pond 69 here has a pond on 2 sides of it. And the adjacent road index and forest index are a little bit different. So this is a 0 to 4 range based on the number of pond sides that have a road or forest within 35 meters. And I only counted if it extended at least 50% or more down that side. So for example, pond 71 here has forest on 2 sides of the pond, but it only has road on 1 side of the pond because this road does not extend down 50% or more of this side of the pond. And this is not a road, it is a levee that might be used with an ATV or something, but it's not a road. And then this is just an overview of all of the management and spatial level variables that I included in the study. So, after the aerial surveys, myself and a team from the USDA went out to farms to try and collect cormorants for diet analysis. Our goal was about 5 birds per farm per collection period, so about 50 birds per collection period. And we went to farms, a random selection of 10 farms from the subset of farms where I observed cormorants during the aerial survey. Once we collected cormorants, we removed the stomachs and counted, identified, measured, and weighed all the prey items within. And we took total lengths and total weights from the fish that we could. So the fish in the example here, we were able to get a total weight and length on because it was mostly intact. But a lot of times the head was missing, so we would have to take partial length measurements and partial weight measurements. Typically, this was, for catfish at least, the base of the anal fin here to the tip end of the caudal fin. And then we would use species-specific regressions to recreate the total length, and then species-specific equations to recreate the total weight. And then we did stats to assess the differences in years, species, catfish consumed, and cormorant sex-based differences. Okay, so during the aerial surveys, we are only capturing a subset of the true number of cormorants on each pond and the true number of cormorants that are present on aquaculture. We identified 3 different sources of what I'm calling bias that we can account for to better improve the accuracy of our measures. So the first is observer bias. Did I tend to undercount or overcount when I was up in the plane? Turnover rate, so how many individuals were on aquaculture and left and replaced by other cormorants that were not counted. Availability was how many cormorants were there but were not seen. So Farmer Joe right next door, 50 meters down the road, might have 100 cormorants on his pond, but I didn't count those because I was only counting on the farms that were within my study. And this is that exercise that I was talking about. So can I get someone in here to be a volunteer observer? You can't do it. You know what you know what it is.
Oh, people at home can participate. Home can participate.
Sure. Okay. All right. So what I want you to do is try and count the number of cormorants in this image. Try and group it into groups of 10. Okay.
Try and group it in groups of 10.
Yeah. You're going fast.
106.
Okay. If we try.
4 to 6 groups of 10.
I mean, you're going fast. It's really hard to gather that much information while also identifying what is a cormorant and is not. And you almost hit a cormorant. That could have taken the whole plane down, and then you would have actually been sleeping with the fishes. So if we try and break that down into groups of 10, we have about 8 groups of 10 with 3 up top. So that's about 83 cormorants maybe. But if we actually count, there are 93 cormorants in this image. So then the observer bias estimate becomes the proportional difference between my observer counts and the image counts. Then we multiply that by our turnover rate correction and the availability correction. And then altogether, we get the adjusted counts. Then we take those adjusted counts, sum it to each survey date, convert survey date into the days through winter. So the final day of September is day 0, and the first day of May is day 214 or day 213 if you're year 2 because it was a leap year and nothing can be straightforward. So we then set those dates to 0 to reflect that cormorants are no longer on the aquaculture landscape, theoretically. So day 1, it stays between October and the last day of the study is in April. Okay, then we sum that to get the bird use days for the region. And now this is where it starts to get complicated with the hurdle model. So in our counts, we observed overdispersion and zero inflation within the data. And all that means is that there were a lot of times that I saw 0 cormorants on a pond. There were also many times that I observed well over 300 cormorants on a pond. So there's a high variation in what is on these ponds with a lot of zeros. And a hurdle model allows us to separate model occupancy, whether a cormorant was there or it was not, separate from the abundance, so how many cormorants were on a pond. And this resolves both of those issues. Oh, yes, thank you. We did test a bunch of other models, but the hurdle model had the lowest AIC score of those. So this is our absolute beast of a global model with all of the variables included. So what we have to do then is begin simplifying the model. So I have the full set of variables within each component, the occupancy component of the hurdle model and the abundance component of the hurdle model. And then I look, are there any multicollinearity between the variables? So we observed that batching strategy and species stocked were significantly correlated with each other, which makes sense. As I said, hybrid catfish are typically stocked in single batch, with channel catfish being mostly stocked in multi-batch. And this has been an issue in previous Delta literature as well. Then I have to select what variable I want to include in my study, and I ultimately chose batching strategy because it is more reflective of the totality of management variables other than just species stocked. So, like, for example, a cormorant's not going to be, ooh, man, I really love hybrid catfish. They're so much more tasty than channel catfish. It's really like trying to compare a McDonald's fry to a Arby's curly fry. There's just no comparison. So then I shifted focus to each component of the model and began selecting which variables need to stay in the model. So I started off with the variables that were least significant and tested dropping them from the model. If dropping that model improved the AIC score, then that variable stayed out of the model, and that new model became the baseline for further comparison. So we eliminated a lot from the abundance component, and then we changed focus to the occupancy component and did about the same. But there were fewer variables dropped out of the occupancy component. So these are our simplified models now, much more manageable. And from that, we can get the occupancy probability and the expected abundance when a pond is occupied. And then the hurdle model combines that to get expected use for a pond. And expected use just combines the occupancy probability with when it is occupied. So, for example, pond A and pond C both were occupied like 80% of the time. But when pond A was occupied, the conditional abundance was 50 birds, but pond C, it was 10. So the expected use for pond A is much higher than it is for pond C. And from that, we can get our estimates of effect. I can bootstrap some confidence intervals for those estimates of effect, and we can get some graphs, which leads me into the wow. So just a little bit of summary stats here. The average pond size in the Black Belt of Mississippi was much smaller than that of Alabama. And Mississippi stocked hybrids and channel catfish fairly equally with reflective multi-batch versus single batch. But Alabama stocked channel a lot more frequently than they did hybrid with reflective multi-batch and single batch production. And then for the diet, I have year 1 and year 2 up top, but the patterns are the same. So just looking at the pooled data on the bottom, overall, we saw mostly shad being consumed, followed by catfish and then sunfish. So that's like bluegill. And of those catfish that were consumed, most of them were channel catfish, followed by 21% hybrid catfish. And on average, cormorants were eating 2.4 channel catfish per cormorant when they were consumed at 102 grams. And when hybrids were consumed, it was 1.4 hybrids per cormorant at 70.9 grams. So overall, we saw channel catfish length was a lot wider than that of the hybrid catfish length. They were typically a little bit longer as well. And all of this is based off of 275 cormorants who graciously donated their bodies to science. And that is what 275 cormorants looks like in one screen. I counted.
In groups of 10?
And of those 275 cormorants, 67% were male, and they consumed around 56% of the total catfish biomass. And males and females were eating approximately equal amounts of channel versus hybrid at about the same size, the weight. Females were eating a little bit smaller catfish than males were, but it was not statistically significant. Okay, so we did see that the amount of catfish consumed did vary based on season, but it was not statistically significant. However, I think it's important to point out these seasonal differences because they will reflect the abundance as well. So in October, we see a small peak in catfish consumption, followed by the larger peak between March and April. And overall, we did not get as many samples as we could have, so that might influence our ability to assess these patterns. I also wanted to point out that 60% of the stocking events on the farms that I studied occurred between January and March, with 30% in January and then decreasing number of stocking events. So overall, farms are stocking right before that big peak in cormorant catfish consumption, which is also reflected in the abundance of cormorants. Year 1, we see those 2 peaks, but we just saw fewer overall cormorants, though we also had fewer aerial surveys. And in year 2, we see a more distinct pattern, but again, we did not get all of the aerial surveys that we wanted to in. So in January of year 2, we did not get any aerial surveys in, and in year 1, we did not get any aerial surveys in October. Okay, moving into the spatial and habitat use results. There's a lot going in these slides. So I'm just going to kind of walk you through the components first. So the dots are bend model predictions. So it's what the model is estimating the effect of that variable for ponds that have all of the other suites of variables attached as well. And the partial dependence curve, the dotted line, is what the model expects for just that variable. So for just pond area, the model is predicting that. And they generally follow each other. And then there's a rug plot at the bottom showing actual data points. And there are bootstrapped confidence intervals around the bin model predictions. Okay, those are all the components. And then we can move into occupancy probability, top left, and expected abundance, top right. So overall, we saw increased occupancy of cormorants and expected abundance of cormorants as pond area increased. And this was our strongest predictor. Oh, and at the bottom is the expected use of a pond. We saw a similar trend as the distance from the nearest activity center increased, so too did cormorant occupancy and abundance, and therefore the expected use. A negative trend with, are the lights dim? Sorry.
It did flicker.
Okay. I was worried that I was going to faint for a second. It's okay. The road within 35 meters of a pond, we generally saw as the amount of road around a pond increased, the expected occupancy and abundance decreased. And then so too did the expected use. Neighboring ponds is interesting because we saw, at least for the partial dependence curve, that's what the model is expecting based on just that variable, that as the number of neighboring ponds increased, the occupancy decreased, but the abundance increased. And what that just is telling us is that cormorants are using these ponds less, but when they are on ponds, there's going to be more cormorants. So it generally kind of levels out in the expected use plot. And the 9 is got such a large confidence around it because there were very few ponds that had 9 ponds around it. Okay, and then this is moving into the variables that were only in the occupancy component. They were eliminated from the abundance component. As farm size increased, we saw greater occupancy of cormorants for greater farm sizes. The reverse trend for the months since a pond was stocked, as the number of months increased since a pond was stocked, we saw a decrease in the expected cormorant occupancy. We saw more cormorants, or a greater occupancy of cormorants on levee ponds than we did watershed ponds, but the effect was negligible. As the average size of catfish stocked in a pond increased, we saw a decrease in the expected cormorant use. Same for aeration. As aeration increased, so too did the expected occupancy of cormorants on a pond. As forest within 35 meters increased, so on all 4 sides of a pond, we saw increased expected cormorant occupancy, and the confidence interval for 4 looks so wonky because there were only 19 farms that had a forest on all sides of a pond. Okay, so in summary, the ideal pond for a cormorant based on occupancy was a large pond close to other ponds on larger farms, as well as ponds that are less disturbed and more isolated, so higher forest, further from human activity, fewer roads, as well as pond conditions that are associated with fish availability and management intensity. So smaller size stocked, fewer months in stocking, and on levee ponds. Based on abundance, cormorants were more likely or occupied larger ponds close to other ponds and ponds that are further from human activity with fewer nearby roads. And all of these trends generally followed what we have observed in the Delta region with increased occupancy on levee ponds, increased occupancy on larger ponds. So I also saw increased abundance on larger ponds. Other studies have looked at the distance to forest. We looked at the amount of forest within 35 meters. And though they kind of measure two different things, we saw a similar trend in the occupancy. Other studies have also looked at the distance to activity centers. We saw a similar result with the occupancy and abundance. We observed a decrease in the occupancy with increased number of ponds within 35 meters. And other studies looked at the distance to other ponds. So again, they kind of measure different things, though my variable has a distance measurement baked into it. And we saw increased abundance as the number of ponds within 35 meters increased. And a lot of studies, as I said before, have examined distance and proximity of roost sites to aquaculture. But roost site was dropped from both the occupancy model and the occupancy component of the hurdle model, as well as the abundance component of the hurdle model. But we, in both cases, Delta and in my study, have observed peak consumption and abundance February through April. And what does that mean for a catfish producer? They can maximize the harassment efficiency around peaks in cormorant abundance. So November is that smaller peak, followed by February, March, and April, which is that larger peak, after stocking times, and on more isolated ponds. But we can minimize, ideally, cormorants on ponds by reducing pond size. However, that has its own suite of issues, such as you're going to have downtime while a pond is not stocked with catfish. You're not able to produce and you're not able to gain harvest. And as I said, there's a very thin profit margin for farmers. And it costs money to reconstruct a pond. Farms can potentially stock later, towards the end of March, potentially right before water's starting to warm up and catfish are eating again. But then a lot of farms are hindered by the fingerling availability from hatcheries. And potentially you can stock more heavily or invest your stocking in farms that are more easily monitored. And overall, the key takeaways that I want you to walk away from this very long presentation are that cormorant diet is opportunistically driven, with more males than females using aquaculture, but they have about equivalent per bird consumption. And that peak consumption and abundance occurred between February and April, with pond size being the greatest predictor of that abundance and occupancy. And different variables affect occupancy than they do the abundance. And with that, I would like to thank the Catfish Farms of Alabama and Mississippi, the USDA Southern Regional Aquaculture Center for the funding, the Alabama Fish Farming Center personnel, aka Jesse James. He was Jesse James in the field. He collected many of the cormorants that we had, as well as the USDA National Wildlife Research personnel who made this all possible, and the undergraduate students who really helped me do necropsies in the lab. And they are pictured here. At that, I will take questions.
All righty, well, thank you.
Thank you.
We do have plenty of time for questions for those joining us via Zoom. I don't have the command and control. Let's see who raises their hand. So I guess just go ahead. If you do have a question, please just, oh, there's a hand up right there. I do see that. So,
I think he's clapping now.
oh, he's clapping. Okay. But either here or for those joining us remotely, if you have a question, please just chime in.
I'll start it off. Do you think stock and shad could be a strategy to reduce